based on the kind of customers that you were coming to your store. Okay, so one of the things that we did, going back to the fire service data, was we ranked the responses. So we got our cluster analysis, and this grouped the analysis into families, and we were able to identify types of incident, and then we ranked those types of incident in terms of which was the most common and which was the least common. And here we've got the top 15. And you can see that really the top 2 incidents don't require any interaction. It's very quick. It's very quickly apparent that these incidents are not needing of the fire service. So the top 2 incidents that come through do not need the fire service. The next one incident, number 3, yes, that does require a fire engine to dispatch. We can see here that the final kind of entry, mobilized rest mobile. So this is an engine, a fire engine has been dispatched. But the next 2 close. So in these 2 incidents, yes, they probably needed the fire service, but when we work our way through it, we do not need to dispatch an engine. We do not need to dispatch an engine. So again, we can see that in terms of the kind of common incidents that we're dealing with, the most common incidents do not require the fire service. And of the kind of top 5 incidents, in only one of those do we have to send an engine. So again, you can staff your fire service, you can staff your fire engines, you can equip things in such a way to account for this kind of insight. The majority of the incidents that come through do not require somebody to mobilize a fire engine. And maybe that's the same with the kind of shoppers that we're dealing with. The majority of the shoppers that come through our store go around our store in this particular sequence, in this particular way. So we need to structure our store in this particular way. They are purchasing these kind of products. There's a degree of commonality around the products that they're creating, that they're purchasing. There is no reason why we cannot perform sequence analysis on users' shopping baskets. Why not perform sequence analysis on users' shopping baskets? Look for kind of common patterns around the kind of products that people buy, and maybe recommend products based on the kind of products that people buy, the clusters of things that people buy. Maybe start and group things together based on the clusters of products that people buy. So you can perform this kind of analysis on shopping baskets as well. Okay, so you could identify typical buying patterns. These families of customer, this type of customer, they typically buy these kind of products. And based on that, I could recommend this kind of product. So you're a customer, you live within family type A that we've identified using this sequence analysis that, that you're a type of customer that lives in this sequence, you buy these kind of products. Well, I noticed that on this particular shopping incident or this particular shopping outing, you've not bought an umbrella, you've not bought some tea, so perhaps I could recommend that for you. Perhaps I could give you a discount voucher for a product that you've not purchased for a while, something like that. But we can identify all that from the sequence analysis. We can identify how people pass through our shop. Is the way that our products are laid out on the shelves the best way? How do people move through the shop? Do they run through it? Do they move quickly? There are areas of the shop that people never venture to. Do the products in that particular area never get sold? Are there areas of the shop that everybody ventures to? Because if there are, maybe that's where we need to be putting our offers. Maybe that's where we get advertisers in. People promoting their products. If we can identify and prove that an area of the shop is most likely to have foot traffic through it, then maybe we could charge our advertisers a bit more to advertise in that particular area or to place their products in that particular area. Maybe we have products that we really want to sell. Maybe they have the highest markup, maybe they have the highest profit. We could put those products in that particular area just from identifying how people pass through our shop. We could start and understand which pattern, which type of shopper, which pattern through our store produces the highest amount of profit, and then we could start and ensure or start and influence people to take that passage through the shop in order to increase the amount of profit that we're generating. So for ourselves, what we did, having done the sequence analysis on the fire service data, and then having identified and ranked these sequences, we went on and looked at the staff. So there are operators at the end of the phone who receive the calls from the members of the public, and these operators are identified on this particular graph, and I've covered up their identities with this kind of black line just to maintain anonymity. This is an ongoing research project, so I have to be careful with these things. So we've got kind of the operators here, and then these row labels down the side. These row labels relate to these particular incidents that we saw here. So the row labels down the side relate to these incident clusters here, and this allows us to see. This allows us to see which operator used which cluster and how many times they used that cluster. Now, the reason for doing that, if you are, in our particular case, if you are responding to an incident, there is a set way of responding. The operators are trained that in the event of a car accident, you need to obtain this kind of information, how many vehicles were involved, the location, who's injured, this kind of information. So there is a set procedure that people need to follow. And getting this kind of cluster information, we can see how often the operators are following these sequences. And that has an impact on staff training and how we train the operators. We could maybe look at this data and see that somebody uses a particular cluster far more times. So we can see in this first column, row label number 3, this particular operator uses that particular cluster 76 times. So we can see that this particular cluster, number 3, which results in an engine being deployed, that particular cluster is used by this first operator 76 times. And yet it's used by this sixth operator only once. Now, why is it that it's only used once by this particular operator and 76 times by this particular operator? Is it because this particular operator works at night? Is it because they were a supervisor? Is it because they're not particularly well trained and don't know about that sequence? So if we start and map those sequences of incident response, if we start and map them against the operator, we can start and identify who's using what sequence, how often, and then we can start and dig a bit deeper and decide if people need training. So from your own point of view, from a more commercial point of view, that would allow us to kind of identify which shoppers belonged to which clusters. So if you had loyalty cards and store cards which would enable you to identify your shoppers, a known identity of shoppers, and then you had the various clusters which were maybe the contents of a shopping basket, or maybe you could do the same analysis for the pattern, the way a shopper moves through a shop. All of a sudden you can start and see which shoppers correspond, or which shoppers are affiliated with which particular cluster. And again, that gives you more insight into the kind of person who is using your store, the kind of person who is purchasing from you. So maybe you could identify shoppers by which cluster they're belonging to. Maybe you can gain, or you could gain more insight into their buying habits, into their patterns, and based on that, you could start and generate offers based on a particular buying pattern. So if a shopper is identified and matched with a particular cluster, you could then generate offers which were targeted at that cluster and be far more acceptable to that particular customer. So rather than generating offers which a customer is going to ignore, which are not going to encourage your customer to come back to your store, you're able to generate offers which are far more targeted and far more likely to succeed and bring a shopper back into your store, increase footfall, increase buying, and increase profit. So there's a commercial application for that. Okay, so throughout this presentation we've had a look at sequence analysis. I've spoken about how we've used sequence analysis when we've been analysing data from the fire service, and we intend to go on doing that and expand the breadth of data and the breadth of analysis and hopefully help the fire service through some of the changes that they want to make. And hopefully I've identified some of the ways that you could use those similar techniques within a more commercial sphere. And I've used the example of a supermarket, of a shopping chain, where you could invest and utilize the benefits of store cards and kind of footfall mapping. So now I shall throw it back to my colleague and ask if anybody has any questions. If anybody would like to ask any questions, I'll try my best to answer them.
Well, thanks, Steve, for the wonderful session. We have questions pouring in from the users. I've started assigning them to you. I hope you can see them.
Yeah. Views for optimizing traffic light timings. Are there any? How do we consider them? How do we decide what level we need to? Once you look at the data for past 13 years, with all columns fields fully populated, with the missing data, or if the data was missing, how do you make sure that it gets populated, or if you've left things around? Okay, SWAYAM. Let's start with SWAYAM because SWAYAM was first in there. Once you took the data for the past 13 years, was all the column and fields fully populated? Were there missing